Hello everyone, this is day 4, problem 1 of our Leetcode activity. Given an array of integer nums, sort the array in ascending order and return it. You must solve the problem without using any built-in functions in n log n time complexity and with the smallest space complexity possible. So the main catch is we have to not use any built-in functions, or we would have just simply called the sort function sort nums dot begin comma nums dot end, and we were sorted. But here we have to not use that. So here we will implement an algorithm called merge sort, which runs on average even for large inputs in n log n time complexity. So this is the code for it. But this code right now looks really intimidating, large, bulky, and unclear. So let us first understand it through an example. So it's 5231. Okay. So this is our 5231. So in merge sort, first of all, let me explain to you conceptually what exactly we do in it. We divide the array recursively into halves. Like we will calculate mid and we'll split this array in half here. So one half will be 5 2, other half will be 3 1. Again we'll do this recursively until and unless we find single elements, or we'll find L equal to R. So here L was this, R was this, we found the mid, we split it. Again here L was here, R was here, we found the split, and we again split it to 5 and 2. This will be split here, this is L, this is R, this will be split into 3, and this will be split into 1. 3 and 1. Now here see L R L R L R L R. Here L equals R. So this is the point we return. We have found, or we have boiled down our arrays recursively, halving it each time to single elements. Now we'll start merging these elements using the same technique used in merge sorted list, which is two pointer. So now this will merge, but it will merge sorted. So when these two will merge, we'll get 2 comma 5. When these two will merge, we will get 1 comma 3. Now at this point again we have this here, we have this here. Now again these two will merge and we'll get the final 1 2 3 5, which is our sorted array. Now how does this merge in? How do we merge this? So think of this. This here is our I, here is our j. Now we'll compare I and j. Who is smaller? J. So j will be added to our merge list, merged array, and j will be incremented. So now j is here. Again compare j and I. Now I is less. So I will be added, I will be incremented here, Again, compare I and j. This time j is smaller, so j will be added and j will be incremented and it will go out of bound. But this condition is handled in the code and we will see it in the code itself. And now these all the elements of this side of the array, this half of the array are covered. So we'll just simply add all the elements in this, which is 5, and we will have our final sorted array. So what are the steps we followed? Steps we followed are simple. Recursively boil down the array, halving it each time. At each step we split the array at the middle on each step and recursively do this until and unless we boil down the array to single elements. So that is, we will do this 3 5 3 1, then this 2 will 5 2 3 1. Now we have gotten our single elements. Now we'll start merging this. So here with this will be I, this will be j. So compare I j. J is smaller, 2 is added, j goes out of bound. So we add all which is here, which is 5. Now we do the same for this side. We do the same for this side. This is I, this is j. J is smaller, so j will be added. This goes out of bound, and we add all things here, which is 3. Again, now here will be I, here will be j. As we merge these two, so here j is smaller, so j will be added. J goes to 3. I j, again I is smaller. I goes to 5, incremented 5 and 3, 3 is smaller. J goes out of bound, and we add all in here, which is 5. So I'm explaining this 2 times that you get thorough with this. Merge sort is really a important concept, and it is one of the internal implementations of sort function used in CPP. So actually CPP uses hybrid of, I guess, merge, quick sort, and heap sort. Now let us look at the code implementation of this. First of all, we pass our array to merge sort. Now when we go and merge sort, what we do, if left equals to right, return. This is our final condition, the base condition, when we boil down the array down to single elements. Now int mid left, we calculate mid and we sort it, we split that array. Then again, when once we have found the mid and now we want to split the array, we'll again pass nums left mid. So basically, this was our array 5 3 2 1. So we found this mid, so nums left to mid. So this is our left. Int left, you can see here, int left was passed 0. So left is equal to nums left. So this is the first element, which is 5 to mid. So this was 3 here, and again mid plus 1 to right, so 2 and 1. So here we split the initial array in 2, 5 3 2 1. Now here, and again, when here we are calling again merge sort now. So Again this will split into 3 5 2 1, and when we hit the base case, this will return. Now this part we have recursively boiled down our array, splitting it exactly in the middle each time down to single element. This is done. Now when we return this, now we call for merge. Now what does merge do here? What does merge do? It declares a temporary array. It declares a temporary array. This will, so here we declared a temporary array of size right minus left plus 1. So basically the size of what we have to merge. So this is 2. So right minus left plus 1. So for this example, the temp will be of size 2. Now we declare int I is left, int j is mid plus 1. Why? Cause in phi 3 mid was here. So this is left and mid plus 1 is 3. So this is in 3 phi, this is I, this is j. Now when while I is less than equal to mid and j is less than equal to right, so I should not go beyond mid and j should not go beyond right, which is out of bound. So you will not understand this here, but when we go further, I'll explain that. Now temps k plus plus is equal to, what is k? K is 0. So k plus plus equal to nums I less than equal to j, nums j. If this is true, we'll do nums I plus plus, or we'll do nums j plus plus. So this is where we are checking that is j greater or I greater or j greater, and whoever is smaller in them both will add that value. And while I is less than equal to mid and j is less than equal to right, temp k plus plus is equal to I plus plus, temp k plus plus is equal to temp k plus plus is equal to nums k j plus plus. Now what is happening here? Here, when once we do all those things, we are adding these things to our temporary array, and at last we'll add our temporary array to our main array. So now here you can see it is going from x raised to x is equal to 0 to k less x equal to less than k. Nums left plus x equal to temp, and this is going k times. So what is happening here is this whatever merge function was called for, that is something LR, but the original nums array is from 0 to n. So this LR sits somewhere in between. So we need to add it in exact place. So this is what this for loop is doing. It is adding this merged in exact its correct place. Now let us also run this for the higher thing, which was for 3 5, and here it was 2 1. So now here you can see I will be left, j will be mid plus 1, Mid was here, so mid plus 1 is here. Now I less than equal to mid. So I should not pass mid. That is mid. That is, it should not pass its boundary here. And j should not pass right. It can be equal to right, but it should not pass right as it is going out of bound. And this is the condition where we check our out of bound condition. So this is the implementation of merge sort, and in such a way we can achieve a sorted array without using built-in function. So this is just one of the methods to do it, but there is also quick sort, bubble sort, insertion sort, selection sort, counting sort. There are many sorting techniques out there. I'll highly encourage you all to go learn them. Thank you.